the last part of our lesson that we're going to visit today is the key attribute section for our cubic and cube root functions. So we're going to talk about how to find each of the attributes by hand, but then of course you could also graph them and use Desmos to find them as well. So first function I have is cube root of x plus 1 minus 1. So if we were talking transformations, we know that this would shift left 1 unit and down 1 unit, which gives us our rotational symmetry point. So our rotational symmetry point is going to be at -1, -1, which is our C, comma, D value. Okay, once again, this has 180-degree rotational symmetry about that point. And when I say about that point, that just means that -1, -1 is the point where I would put my finger on, spin the graph, and it would land back on itself before it made that full circle. Okay, so we have a rotational symmetry point about the point -1, -1. So rotational symmetry point is like getting your vertex from the equation. We've gotten really good at that throughout the year. Okay, next thing it asks us to find is domain and range. Well, guess what? Domain and range for this whole entire unit, remember, is all real numbers. There are no endpoints on either. So we have arrows on both ends going up, down, side, side. Okay, range is the same thing. I'm going to write it in a different notation just so that we continue to see it presented various ways. So another way to say all real numbers is from -infinity to +infinity. Okay, finding our x-intercept, we will plug in 0 for y. And solve. Whoops. Okay, and then for y-intercept, we're going to plug in 0 for x and solve. So we're going to do x first. So I have, remember, f of x is the same thing as y. So for x-intercept, 0 for y equals cube root x plus 1 minus 1. Okay, so we're going to add the 1. 1 equals cube root of x plus 1. To get rid of the cube root, the inverse of this function is to cube both sides. So I get 1 equals x plus 1. When I subtract 1, we find out x equals 0. So this is going to cross the x-axis at 0. For our y-intercept, we're going to plug in a 0 for x. So y equals the cube root of 0 plus 1 minus 1. The cube root of 1 is 1. So y equals 1 minus 1, or 0. So for both of these, we would write it as an ordered pair. So my x-intercept is at 0, 0. My y-intercept is also at 0, 0. Okay. For your x-intercept, y is always 0. For your y-intercept, x is always 0. And then you plug in the answer you get for the other part of the ordered pair. So this one happens to go through the origin, which is why the x and y-intercepts are both 0, 0. Okay, let's do one last example. So that was a cube root. Let's do a cubic. Okay, we'll do this one. So first thing we want to know is the rotational symmetry point. Sorry. Rotational symmetry point, which is at the point CD, or 1, 16. My domain and my range are both -infinity to infinity. For my x-intercept, I'm going to plug in a 0 for y, and then I have 2 times x minus 1 cubed plus 16. And we're going to solve for the x. So -16 minus 16. -16 equals 2 times x minus 1 cubed. Divide by 2. So -8 equals x minus 1 cubed. we're going to go ahead and take the cube root of both sides. So I want to know what number times itself equals -8. Cube root of -8 is -2. So -2 equals x minus 1. And when I add the 1 over, we find out that x equals -1. Okay, so my x-intercept is at the point -1, comma 0. When I plugged in a 0 for y, my x value is -1. And then the last thing we want to do is find our y-intercept. So we plug in a 0 for x. Y equals 2 times 0 minus 1 cubed plus 16. So y equals 2. -1 cubed is -1. 2 times -1. So y is -2 plus 16, or positive 14. We write it as an ordered pair. We get 0, comma 14. So here my y-intercept is at 0, comma 14. And of course, like I said earlier, you could type it into Desmos and check all of these answers.